to understand how we can better feed cows, it is key to having a basic understanding of how the rumen actually works. So I've drawn up a rough rumen. You can see that the cow's gut consists of 4 main compartments, with the rumen being the largest compartment. It feeds directly into the reticulum. So the reticulum is actually still part of the same chamber as the rumen, but performs a slightly specialised role. The reticulum feeds into the omasum, which then feeds through to the abomasum. Now the abomasum is like a true stomach. It's like the stomach of a human or the stomach of a monogastric. It's where there are digestive juices and acids secreted, and it's the true site for digestion. What we're more concerned about today is the role that the rumen plays and the fermentation that occurs in here. So if we have a look at the rumen, it's got a liquid phase down the bottom and a gas phase sitting up above, and there's a fibre raft that sits along the top of that liquid phase, floats on the liquid if you like. Now this fibre raft plays a couple of key roles. One is that food from the mouth tends to get trapped here, and from there the bacteria can jump on it and fermentation can properly begin. The second thing, the fibre actually helps scratch the wall of the rumen, and the rumen will contract. Now you see that the rumen's sort of split into sacs, and these sacs are divided by what they call pillars, and it's the shortening of these pillars that actually cause contractions. So contractions generally start from the bottom left here and move upwards that way. So if we have a look at a bolus of food, which is a chewed up ball of food, will come from the mouth and come down and gets lodged in the fibre raft here. When the rumen contracts, it will actually lift this liquid phase. There's less space here, so the liquid all moves up, and effectively that bolus is dunked into the liquid part of the rumen. The liquid is actually where most of the microbes within the rumen lives. A few will live along the walls and sit in the fibre, but the majority of the microflora are here within the liquid phase. So this will include bacteria, protozoa, fungi. The bacteria will basically jump onto the food and begin the process of fermentation. Now when they ferment, any carbohydrates, or what we think of as energy within the food, is turned into volatile fatty acids, which are actually metabolizable energy for the cow. These are absorbed through the rumen wall primarily. They will also reshuffle protein and break it down into amino acids, and ammonia. Ammonia can also be absorbed through the rumen wall here. The amino acids are basically used for their own growth and their reproduction. They reshuffle them into sequences that they need, and they themselves will reproduce and grow. Now the bugs play a very important role in all this fermentation, but they play equally or perhaps even greater importance in the fact that they themselves become food for the cow. So when the rumen contracts and this liquid phase lifts up, not only is the food bolus dunked, but a lot of liquid will actually escape through to the reticulum. Now, as I said before, the reticulum is part of this same chamber as the rumen, but its role is actually to act as a bit of a filter. So anything that is small enough will make its way through the reticulum and into the omasum. But any large objects, such as undigested food, will actually be regurgitated. There are sensors in here that allow for that to happen, and this is also called rumination. It's actually one of the main reasons that ruminants are called ruminants. As I said, anything small enough, including microbes, will get washed through into the omasum. Now the omasum wall, the internal wall of the omasum, consists of what they call leaves or flaps. And one of the key roles of the omasum is actually to grind this food down a bit further, so help with breakdown. It's also a big site for water absorption, so a lot of the liquid is then removed from the omasum, absorbed into the cow system, and finally we get the passing into the abomasum, which is where the acids will be secreted and is the site for true digestion. Okay, one of the key messages to come out of this is that what we actually feed the cow is not necessarily cow food. What we are doing is feeding the microbes within the rumen, and they are then responsible for turning that into substances that the cow herself can use. Where DFM is important is that it delivers bacteria, yeast and enzymes which do act within this rumen environment. They are specifically chosen to help improve the performance of some of the bacteria that are already there and reduce the performance of any pathogenic bacteria. They play a second role further down through this system, down within the intestine. And here they play an added role. They drop the pH through the production of acids down there that prevents pathogenic bacteria from reproducing and growing as well as they'd like. They also outcompete plenty of pathogenic bacteria in this intestine for space to colonise along the walls. So it is important to understand that DFM plays a big role within the rumen as well as a role further down the gastrointestinal tract.